Okay, so this is a video basically explaining the carriage system robot and all of my thoughts about it. So I want to explain everything I have about it so I can get your guys' opinions and comments before I actually do the full CAD, which is going to take a long time. Okay, so let's start off. I have a spreadsheet here. Okay, so the first thing we got to make sure we do is have a low center of gravity, because we're going to be extending this thing really far, or actually, I'll probably explain the robot real quick, what it's going to do. So the robot ends autonomous about right here, so we get the parking bonus. Then we drive into the crater, collect a bunch of the blocks and balls, we sort them, um, blocks go to one side, balls go to the other side, and then we extend all the way to over here, and that extension has a rope or belt on it, where we can then move carriages between here. the the extension stays out while we're moving the carriages. So we just move the carriages in between these two, and determine depending on how fast we can move the carriages determines how fast we can score points. Okay, so how that robot's gonna work. Um, we really need a low center of gravity. So the whole robot that's gonna be catted, all the weight is gonna be right here, right on this wheel, I'm thinking, because that maximizes, yeah, that maximizes our center of gravity. Because what's gonna happen is that when we have this thing lifted out way over here, we're gonna want to tip really badly. So the more weight we can get on this side, the better. Um, yeah, and to help with that too, I also built these forklift things or forks. How they work, I don't know how to power them yet, but they just go down like this, and they're basically used. There's two reasons to have them, but one of them is so that it prevents us from tipping even more by increasing our wheelbase essentially. They also do something else really cool. So when we're extending, it's really, in order to aim for the blocks, we have to aim basically in between those two, which is really hard from this distance. So what I'm saying we do is that we extend, and our linear extrusion is like right here. Um, and then what we do is that we pick up the robot a little bit. So we do that, and that what that does is that it moves our linear extrusion up to here. And this triangle thing acts like a funnel. So if we start there and lift up, it goes up there. Start there, that lift up, it goes up to there because it acts like a funnel. So that means we're always in the same position here, which means that we can always have these blocks be in the same position. And the wiffle balls really don't matter, but if we get this position, this one will be right, and then this one will be right too. So that would be pretty useful. A lot less precision needed. Um, so yeah, another thing that we need to do is try to maximize the amount of blocks and balls we can store in the robot. The progression of balls and blocks getting into the robot is basically going to be we have a sweeper in the middle in order to collect balls and blocks really fast from the arms that are going to be on the outside. The arm's going to act like a tank kind of for us, and then when we need to use them, they're just going to push them into the robot. The sweeper is going to do sweep them all the way up to the top, and then from here there's going to be a separator that separates the blocks onto this side, the balls onto this side, and then they're going to basically roll down ramps on into the carriages. What the carriages look like is basically this piece. The balls and blocks would fit right here, and what would happen is that when this piece hits either this one for the, right here about for the wiffle balls, or like right here for the blocks, what happens is it just goes like bam, it dumps them, and then it's going to be a rubber band from like here to here. So this always wants to stay like this, but when it hits the wall, it does like that. It's super simple. It doesn't require a servo. Probably pretty reliable. So yeah, so they would come up here and then move to either this side or this side, and then move into the carriage. Um, yeah, so that's how that would work. The extension itself, I'm not sure exactly what type of extension we should have. Here's what it would look like with the drawer slides, the miniature drawer slides. I think we need at least six stages. We probably need seven just to be on the safe side, but I think we need six. I think we can get away with six, probably want seven. Um, so yeah, it's gonna take up a lot of space, and yeah, we could also try to use the telescoping fishing poles. Those are gonna be stronger, but I just don't know how to make them extend. These are easy to make them extend. You just put pulleys on the outside, pull the rope, boom, they're extended. Telescoping fishing poles, you can't really do that because you don't have access to the bottom of the pole. But yeah, if we can use telescoping fishing poles, they're lighter, smaller, um, and stronger. So yeah. Um, how we're gonna power that is with two motors, and those two motors can, after powering the extension, they can shift over to powering the carriages. And when they do shift over, the extension will then move into a brake mode. So it's just gonna move the power from the motor to a brake. I'm pretty sure I can do the CAD for it and figure that out. Let's see what else we have. I think so. How the lifting of the robot is gonna go. Um, so the lift is what this thing is when we lift the robot up. Is I think that we should have it a completely separate mechanism. Probably somewhere either on one of these corners right here, or maybe even in the back if we have room. Probably not, to be honest. It's probably gonna be on one of the sides. And the reason to make it a completely separate mechanism is that if even if everything else messes up and fails, we still have the 80 points in the lift. And I think that's essential because we can probably win many qualification matches with just the lifting of the robot. For the team number score, I think that's the simplest thing. You make a ball on the team number, you put the ball in the intake spits it out slowly so we don't be considered shooting. Um, have a list of motors and servos that we're going to use. So I think in total we're going to use 8 motors and 9 servos for this robot. So one for lifting the robot, one servo for this. It's going to be the servo we initially used to keep our robot there so we don't have to have it powered. So at the start of the match, we're going to release the servo, which is going to let the power be taken up by the motor so then we can slowly fall down. The intake, we're going to have one motor to power the sweeper, and we need 2 motors, 2 servos for the arms. The conveyor, um, we need the 2 servos so that we can, when we have the ramp, we don't want all the balls or blocks going from the ramp into these pieces, so we just need like a little gate there to keep them out. Okay, extension slash carriage, we need 2 motors to do both of them, and then we need 1 servo to shift. We might need 2 servo to shift, servos to shift them, but I think we can do it with one. Not entirely sure though. Okay, so the forks, those are these pieces. I don't know how to power them yet. I don't think just putting a servo straight on there will be strong enough. So if you guys have comments about that, please post them. Um, but yeah, we don't really have any servos, so 2 servos for that. Oh, and also on the thing, there's going to be 2 of them, one on this side, one on this side. I just don't have time to CAD them. Same with this, the linear extrusion. There's going to be one on this side, one on this side. Okay, drivetrain, we obviously need 4 motors. The separator, to separate the blocks and balls, we need a single servo. And team flag, we don't need anything. If you guys come up with any other servos or motors that we need to add, please post it in the comments. And I think that's it. So yeah, I need basically your comments so that I can figure out what CAD we should do. It's going to be a lot of, we CAD a test piece, we make it in real life, and then that determines if we can actually do the real thing. Yeah. Like, for example, we're gonna